Hi, in this tutorial I'm going to take a closer look at the TSCARBitmap construct. Now, you may know that previously to SCARDV 3.35, bitmaps were referenced by integer values, and now they are referenced by actual bitmap objects. So the first thing I'm going to do here is just show you a basic usage of the TSCARBitmap, and to do so I'm going to just select like part of my interface here. It's going to be fairly large, okay, and then I'm just going to use the debug bitmap function to output this bitmap into the debug window. So as you can see, it displays the bitmap I just selected over here with the bitmap picker tool. So that's basically how this works, and you'll see a lot of analogs with the old system. For example, the debug bitmap function has not changed except for the fact that now it takes a TSCARBitmap object, and of course you've still got your bitmap string here, but the string now contains the dimensions of the bitmap, and it has to be entered into the TSCARBitmap constructor, so .create here, or the load from string method, but I'll get to that later. So I'll just go through the whole thing one method at a time. So the first thing is immediately alpha blend. Now, aside from being able to search for bitmaps, SCAR also has several methods to allow you to blend images together. To demonstrate this, I've got the test PNG and test BMP images, which are also found in the SCARDV pre-release repository, to demonstrate this to you. So first off, I'm going to save my script to the desktop, and now we'll need to create a TSCARBitmap object. When you create this without entering a bitmap string, the bitmap will just be empty and it won't actually have any dimensions. Now, normally we if we'd want to work with this, we could use set size, or set size mainly, to give the bitmap a size before we start working with it. But in this case, I'm going to use the load from PNG method, and this will allow me to load any PNG file into the TSCARBitmap construct. So that's test png.png. Okay. Now when I run this, you'll see I get the PNG image here with a clear white background. Now this is just because the transparent pixels of the PNG are actually white, but with a high alpha value. However, this is obviously not an alpha blended image. And the reason for this is that, to alpha blend, I have to draw this onto another image. So I'm going to create a second bitmap here. Bitmap 2, like that. And what you'll want to do here is just give this bitmap the same dimensions as my PNG. So assign its width and height to it. Oh, this should be bitmap 2. Okay. And Next, we'll want to fill this bitmap with a solid color. To do this, we can use the clear method. So clear, yeah. And this will just fill the entire bitmap, no matter what's on it, with a single solid color. So in this case, I'm going to use, let's see, let's go for pale green here. Now, when I quickly debug this, you can see we get the pale green image here. So it's just a single color. And the next thing I want to do is draw the PNG onto it. So I'm going to enable alpha blend. Well, you know, let's just try that without first. And the TSCARBitmap function has a draw to method which allows you to draw it to any other bitmap, and they're the same size. So if I draw this to the 0.0 coordinates, it will just cover the entire bitmap. So when I run this now, it shows us the original image without alpha blending. However, when I enable alpha blending here, you can see the PNG image blends in with the green background we had before. So that's basically how alpha blending works in here. And this, of course, is with an alpha blended PNG image, so this one here. But not all images actually have an alpha channel. If we look at this here, this is a small bitmap, and it does have a transparent color, so it's a solid color which represents the area that should be transparent, but it doesn't actually have an alpha channel, so it isn't transparent by default. However, we can also blend this, so I'm going to use the load from BMP method here, and this will enable me to load our BMP file. So when I run this, as you can see, it just prints out the bitmap here. Why doesn't it blend this? Well, alpha blending is enabled, but as I said, the test BMP does not have an alpha channel, so there's none loaded in here. Now, to actually get this to blend, we will need to tell the bitmap, well, the TSCARBitmap construct, that the transparent color here, which is fuchsia, is actually supposed to be transparent. And to do that, we have to use the transp color field, well, property. However, do take in mind, this is also used for transparent bitmap searches, but I'll explain that later. So we'll just set this to CL fuchsia, like that. And when we run this now, it apparently still does the same thing. Okay, yeah, this has to, you have to enable alpha blending before setting the transparent color if you want to use alpha blending. So as you can see, the image is now nicely blended in here. So that's basically how the alpha blend field, well, property works. And let's see, what's the next thing? Okay, so you've got assign and assign to. Now, these are sort of funky properties. They basically allow you to get a bitmap from any supported object, or set any supported object to the bitmap within the TSCARBitmap construct. Now, there's several types that are supported. Of course, you've got the TSCARBitmap type. There's also the tBitmap, and of course tImage. Now, I'm only going to demonstrate this with TSCARBitmap, and do take in mind that for example, T image, you might need to synchronize with the main thread in case you're using this with forms. However, I'm just going to use our bitmap2 here again, and we'll call the assign property, well, method here, and let's just get rid of that. This will essentially assign our first bitmap, which we loaded from test BMP, to the second bitmap. So as you can see, the second bitmap was printed out as the same image we loaded into the first one. We can also switch this around and use assign to, and this will do exactly the same. So if I comment this out, it won't display anything. So that's basically how the assign and assign to methods work. Now the next thing is the canvas. Now the canvas property is actually derived from the tCanvas object. I suggest you read the Delphi documentation to figure out how this actually works, but this hasn't actually changed from the previous versions where you were also able to access the canvas. So next we've got clear, which I've already shown you, and then there is clone. Now what clone does is it basically creates a new bitmap object which contains the same bitmap as your previous, well, same bitmap and the same properties as your previous bitmap. So I'm going to clone the bitmap here and assign it to the second one. So I'm not creating the second one. It will only, well, the clone method will create one, but just to show you, it prints out our little bitmap here once again. So that's basically what clone does. So if I just comment this out, it will throw a runtime error for debug bitmap that the bitmap is not assigned. Okay, so create, I've already explained that one, that's the constructor. Then we've got DC, that's the device context for the bitmap. Draw to, I've already explained as well, and draw to X just allows you to do the same thing. However, this allows you to draw a bitmap to a specific box on your bitmap. Okay, so next we've got the equals method, and this is actually not defined in the TSCARBitmap function, class, sorry, but this is derived from the TObject class, and it allows you to check if one object is the same as the other. This does not compare to bitmaps, so watch out for that. You can't actually check if two bitmaps are the same, only if the objects which represent them are the same. So to do that, you should use the, I think it's compare bitmaps or similar bitmaps function, which allows you to actually compare bitmaps themselves. So then we have the flip method, which allows you to, as the name suggests, flip a bitmap either horizontally if you enter, well, if you pass a true for horizontal, or vertical if you pass false. So I'm just going to give that a shot here, and let's get rid of our second bitmap. So I'm going to flip the bitmap horizontal, and just for funsies I will load the PNG in, since it's a bit larger, so that will give us a better view of that. So first, without flipping it, you've got a nice big PNG image there, and then we're going to flip that horizontally. So that worked pretty good. And vertically, so as you can see, it's flipped correctly there. Then the next method, well, free, allows you to, of course, free the bitmap from memory. This is also done automatically when the script terminates, but it's good practice to do this yourself. So next there's the get alpha mask procedure, well, function. This is rather a special one. This basically allows you to get the alpha mask for, well, which is defined for your bitmap for alpha blending, but it's shifted into the I think blue channel. And of course you can also set the alpha mask. I think there's also a set, yeah, there's also a set method, so that way you can define very specific alpha masks. And well, I'm just going to input this straight into debug bitmap. As you can see, this is the alpha mask in the blue channel for the PNG. So basically everything that's black is fully transparent. Everything that's like here, the shadow of the icon is not entirely transparent, but mostly, so that's somewhat dark blue. Okay, then our next method here is get hash code. Now this also derived from TObject, and it allows you to get the hash code for the object, but this is not really of any use in SCAR at the moment. The height property is also fairly obvious. It returns the height of the bitmap. Then we've got load from BMP, load from JPEG, and load from PNG. These should also be fairly obvious. And load from string, as I mentioned before, you can either enter a bitmap string in the constructor, so the create method, or you can pass it into load from string. Now the next thing is the pixels property, and this basically allows you to get the colors at individual pixels or set them. To quickly demonstrate this, I'll just create a small loop, so I'll need a variable for that. Let's say from 10 to, I'm not sure how wide it is, let's say 50 do, and I'm just going to add let's say the 20th row, so the row started the 0 index. I'm going to set the pixels for an entire row of 40 pixels to, let's say, red. And as you can see, you've got a little red line here, which is what we have just set. So I can, for example, make that a square if I would replace this here. So that will nicely generate a red square there. Of course, as I mentioned, the pixels property allows you to both set and get the colors at a certain pixel. So after that, we've got the resize method. This allows you to change the size of your image. For example, I can change it to 500 by 500 pixels, and you get resized bitmap. Now take in mind that this does not equal the set size method which I've mentioned earlier. This just resizes the canvas and discards the image, so you'll just get a black bitmap after that. Okay, so after resize we've got rotate, and this allows you to rotate the bitmap by a certain number of radians. Now let's try just entering 1 in there, and as you can see it has rotated the bitmap by 1 radians. So 180 degrees is pi radians, so if I enter pi divided by 2, it should be about 90 degrees. So as you can see, it just flipped it over there, so that's 90 degrees, and pi should rotate it completely upside down. Okay. Okay, so the next are the save to BMP, save to JPEG, and save to PNG methods. They're obviously also fairly obvious. I'll just give one a shot here. So we loaded this as a PNG image, and I will now save it as a BMP image. As you can see, this is a bitmap image now. The transparency has been lost as bitmaps are being saved as 24-bit bitmaps and not 32-bit maps. Bitmaps, sorry. Okay, so then we have save to string. This allows you to convert a bitmap into a bitmap string dynamically. This can be used to, for example, store them in a database or whatever. And this just shows us the string. For the PNG image, do take in mind that the currently bitmap strings do not retain the alpha channel, so this will not allow you to save the transparency of the bitmap. Then there's set alpha mask, which I've already discussed before. Set size as well. To string doesn't really do much. It will probably print out either an empty string or the class name, or it will just throw a runtime error, whatever works for you. So basically toString is currently not really implemented in SCAR as it's not of that much use. Then transparent color, I've also explained, and then there's width, so that's also very obvious. As I said before, transparent color can also be used in conjunction with finding bitmaps. Normally this is set to -1, so that's basically not a valid color. But when you, with or without alpha planing enabled, set this to a specific color, you will be able to search for the bitmap, but with excluding that color from the bitmap search. So that's basically how that works. And do take in mind, when you have alpha blending enabled, using the transparent color property to set a color will also remove the entire alpha channel and set the color you entered as a transparent color in that alpha channel. So that's about it for the TSCARBitmap. I will see you in the next tutorial.